Properties of solutions. Take 2 test tubes, each half filled with water. Add a pinch of common salt into the first test tube and a pinch of sand into the second. Shake the test tubes. What happens? We see in the test tube containing common salt, the salt disappears, and in the second, sand particles settle down at the bottom of the test tube. Filter the contents. Sand separates from water, whereas common salt does not. This suggests that certain substances, like common salt, in the present case, form a homogeneous mixture with water, and we cannot separate it by simple techniques such as filtration. Such a homogeneous mixture containing 2 or more substances is solution. In the example discussed above, common salt forms solution with water, but sand forms just a heterogeneous mixture. For a solution, any part of it will have same properties, unlike a heterogeneous mixture. Take another example. Dissolve a few grams of copper sulfate, CuSO4 5H2O, in about 100 ml of water and shake gently. A light blue colored solution forms. CuSO4 5H2O plus water is equal to blue colored liquid. A solution consists of 2 parts. Solutions are uniformly colorless or colored depending on the ingredients present in it. The physical properties such as density, refractive index, viscosity are the same in any part of the solution. The solution is thus homogeneous. Solute, solvent and solution. To understand the terms solute, solvent and solution, consider the following example. Take 2 grams of sucrose sugar and add it to 100 ml of water. A sugar solution results. The ingredient which is in less quantity is the solute, and the one which is large in quantity is the solvent. In this example, sugar is solute and water is solvent. Remember, the quantity of solute is always less than that of a solvent. When solute is added to the solvent, the resultant homogeneous mixture is the solution. Thus, solute plus solvent is equal to solution. If the solvent used is water, the resultant solution is the aqueous solution. Suppose 60 grams of alcohol is added to 60 grams of water. Can you name the solvent and solution in this? In such a case, where the quantities are equal, any one of the ingredients is the solute and the other the solvent. Types of solutions. We can classify solutions according to the physical state of solute and solvent. One commonly used method of classification is by quantity of solute present in a given solution. Such a classification is as below: unsaturated, saturated, supersaturated. The amount of solute that can dissolve in a given amount of solvent depends on the nature of solute, nature of the solvent, and temperature. This gives the solubility of the solute. When we keep adding the solute again and again to a solvent, keeping the temperature constant, a stage will reach when the solvent will remain undissolved. Such solutions are the saturated solutions. In other words, a solution which remains in contact with excess of solute is a saturated solution. The solution in which further solute can dissolve is unsaturated solution. The weight in grams of the solute in an unsaturated solution is less than the solubility. On the other hand, it agrees to solubility in saturated solution. When we heat a saturated solution, the undissolved solute present in a saturated solution slowly dissolves as the temperature rises. After dissolution is complete, slowly cool the resultant solution to room temperature without shaking or any other disturbance. The solute which does not dissolve before heating at room temperature now dissolves. This means the solute dissolved in the present solution is more than its solubility. Such a solution is a supersaturated solution. In this solution, the solute present is more than in the saturated solution. A slight disturbance such as shaking, stirring, or scratching the wall of the beaker with a glass rod, or adding a solute crystal makes the solute to precipitate out and a saturated solution results. Thus, such a supersaturated solution is unstable.